In this video, we'll talk about the circumcenter of a triangle. So we'll start by defining the circumcenter and some of its properties, and then we will go into an example on how to find one in a coordinate plane. So the circumcenter is the point of concurrency for the perpendicular bisectors of the triangle. So let's look at our sample triangle. We'll label the vertices A, B, and C. And if we were to draw the perpendicular bisectors, we have to draw lines that would bisect each side and also run perpendicular to it. In order to bisect the side, it must pass through the midpoint of each side. So let's say that this point here is the midpoint of AB, we have the midpoint of BC, and we have the midpoint of AC. And we have to draw lines that run perpendicular to that. And you'll notice we have this point here where they all intersect, and that is our circumcenter. We'll call that point O. Now, as we noted, that in order for this to bisect, it has to pass through the midpoint, so we know that this segment is congruent to that segment, this subsegment and this subsegment are congruent, and this subsegment and this subsegment are congruent. Now, the special property of the circumcenter is that it is equidistant from each vertex. So if I draw a line from point A, or vertex A, to O, and draw a line from O to vertex B, and draw a line from C to point O, these segments are all equal in length. So 1, 2, 3, 4. So that's the special property there. And you'll notice again with perpendicular lines drawn in, as I add in those segment lengths that I just drew in green, we have right triangles that are formed, and we know whenever right triangles pop up, that's useful in many problem-solving applications, so we want to be on the lookout for that. So there's a right triangle there, for instance. Now, the reason it's called a circumcenter is because it is the center of the circumscribed circle. So the circumscribed circle is a circle that passes through each vertex. So I'm going to do this, probably going to turn out terrible, but here's a rough circle that would pass through each vertex of the triangle, and O is the center of that circle. And you'll notice as well that the segments we drew from that circumcenter to each vertex, so highlight it, like this line here, or this line here, or that line there. So those green segments we drew in that are just highlighted, you'll now even notice that with that added in circumscribed circle, that they also represent the radius of that circle, which can be utilized as well in various problem solving applications. So there is the circumcenter, what it's all about. We're going to go into how to find it, which is going to require us to review how to write equations of lines, because what we're going to have to do is find the equations of two perpendicular bisectors, and then we're going to solve that system of equations. So first is we're going to write the equation for two of the perpendicular bisectors. And we only need two because we know the third's going to pass through the same point as well, so it would just be work that's not required. So to write equations for lines, remember we need two things. Those two things are the slope and a point that it passes through. And the point that it passes through, so each perpendicular bisector has to pass through the midpoint of a side. So the point, we're going to use the midpoint of the side that the perpendicular bisector is going through. So we're going to be looking for midpoints there. And then as for slope, well, we're going to be able to calculate the slope of the sides of the triangle because we're going to be given the vertices. So once we calculate the slope of a side of a triangle, we're going to take the negative reciprocal of that in order to have a line that runs perpendicular to it. So it's going to be negative reciprocal of slope of side of triangle. Okay, and just as a reminder, the midpoint, the way we calculate that is we're going to average the x's and we're going to average the y's for the vertices of the triangle that form that side that we're looking to calculate the midpoint of. So once we get those two things, we're going to be able to write the equation of the line. In the equation of the line, we're going to use point slope form, which is y minus y1 equals m x minus x1. So this is our first step. We're going to do this twice. And once we get these two line equations, then what we're going to do after that is rewrite as y equals. We're going to use substitution to get the equation in one variable, which is often going to be x. And then once we have it in terms of just x, we're going to solve for x and then back substitute into the equations to get y. And then once we get y, we have x and y coordinate. We're just going to plot that point to check our answer. So it's going to be a rough check. So we're going to draw in that point and see if it truly does look like the perpendicular bisector point of concurrency. So let's jump into an example now where we have these 3 points, A, B, and C. I'm going to plot those to start. So -5, 3. We're going to do 1, 7, and 7, -5. So there's our triangle. Now, as we mentioned, to find the point of concurrency for our perpendicular bisectors, we have the luxury of picking any two sides we want to use and finding the perpendicular bisectors to that. So let's do the perpendicular bisector to AB to start. So we're going to do perpendicular bisector to AB. So as we mentioned, we need to write the equation of the line, and we're going to write y minus y1 equals m x minus x1. That's our general format. We need a slope. So to get our slope, we got to find the slope of A to B. Now we can count rise over run if we want. So we're rising a +4 and we're running a +6. So the slope would be 4 over 6 or 2/3. So +2/3. We could also calculate it as doing the change in y over the change in x as a reminder if we want to calculate this algebraically or through computation. So just to verify that that's true, we're going to do, this is for AB again, so 7 minus 3 over 1 minus a -5. We're going to get 4 over 6, which is 2 over 3. So the slope from A to B is 2/3. But remember, we don't want the slope of that side to write the equation of this line. In the end, we need to write the equation of the line that runs perpendicular to that. So if the slope of AB, so let's write slope of AB is equal to 2/3. That means the perpendicular slope to AB must equal -3/2. Now, a point that it passes through, it has to pass through the midpoint of that side in order to bisect it. So then we're going to say the midpoint of AB should be equal to, we're going to average the x's, and we're going to average the y's. And we're going to get -4 over 2, comma 10 over 2, which is equal to -2, 5. And just to double check, if I plot -2, 5, that does look like it's right in the middle. So that's the point we're going to use. So now we're going to write the equation. It's going to be y minus the y coordinate of the point it passes through equals the slope, -3/2, x minus the x coordinate. So this is what we get. Now we mentioned before, we're going to want to write this as y equals ultimately. So we're going to put this in slope-intercept form, -3/2 x. Distribute that -3/2, we're going to get -3, but then we have to add the 5 to solve for y. So we're going to get +2 here in the end. So here's our first equation, and let's write that off to the side. So we're going to get y equals -3/2 x plus 2. So that's our first equation there. Now we got to find the equation for one more. This time let's do the perpendicular bisector to AC. So we need a slope. So we're going to find the slope of AC. So the slope of AC, change in y over change in x, or you could count it off. If you're going to count it off, just make sure we're going, so the rise is a negative value, right? Because you're going down. If you're going from A to C. So let's do the calculation. We're going to do -5 minus 3 over 7 plus 5 is our change in y. So -8 over 12, which is -2/3. So our perpendicular slope to AC is going to equal 3/2. Now the point we're going to use is we need to find the midpoint so that our line bisects that side. So the midpoint of AC is going to be, so we're going to average the x's, and we're going to average the y's, and we're going to get 2 over 2, -2 over 2, so 1, -1. And if we plot 1, -1, that does look like it's right in between those two. So we should feel confident about that. So now we can write the equation of the line, y minus the y coordinate. So it's going to be a +1, it's minus a negative, 3/2 x minus 1. We're going to solve this for y. So 3/2 x, and when we distribute, we're going to get -3/2. But then we have to subtract 1, so it's -1. So -2 over 2, so it's going to be -5/2 in total. So let's write that underneath. So there are two equations. Now we have a system that we need to solve. So we solve them both for y so that we can use substitution. So I'm going to substitute this equation here in for y into that. So I just get an equation in terms of one variable x. So we're going to have 3/2 x minus 5/2 equals -3/2 x plus 2. So if I get the x's on the same side, we're going to add 3/2. So 3/2 plus 3/2, right? We're going to add 3/2 x to both sides. But we're also going to add 5/2 to both sides, so I can clear that. So this cancels and this cancels. And we're going to get 6/2 over here, which is 3. So we're going to get 3x equals, and then over here, to add those common denominators, so we're going to get 4 over 2, and we're going to get 9/2. So then we're going to divide by 3 or multiply by 1/3. So it's going to be 9/2 times 1/3, which is equal to 9/6, which is equal to 3 over 2. So x is equal to 1.5. Now to get y, we're going to substitute back into either equation that we used to get the value of x. So it doesn't matter which one. So let's plug it into the top one, let's say, okay? So we're going to say, well, y should equal, if we now know the value at -3/2, and I'll plug in 3/2, and then plus, I think it was 2. So then we're going to get y is equal to -9/4 plus 2. To add these common denominators, we're going to get -9 over 4 plus 8 over 4, which is -1/4. So our x is 1.5, and our y is -0.25. So now let's check, see if this is accurate. So if I plot 1.5, -0.25, I get a point that's right there. Now if I draw in the perpendicular bisectors, so if I actually draw a line that runs perpendicular to this, just a rough sketch. Actually, I could actually draw those lines, and I should. So we had the equations of those lines. So we had, the equations were y equals -3/2 x plus 2, and then we also had y equals 3/2 x minus 5/2. So if I plot that, so -5/2 would be here, and we have a slope of up 3 over 2. So that's that bottom equation. And then the top one, we know it has to pass through this midpoint, and that point did get passed through over here, that midpoint of AC. And then over here, we know we can stem from that. And if I go down 3 over 2, and I have a y-intercept value for that, down 3 over 2. We'll get a line that's accurately drawn like that. And we do see that that point we plotted, 1.5, negative 0.25, there is our circumcenter. So I can actually draw in those lines. I have y-intercepts, and I have the point, and I can just count off the slope from there. I should just use the midpoint. And if I graph those two lines, in addition to the calculated circumcenter, I see that everything lines up, so I should feel confident about this answer. So here is my circumcenter for triangle ABC with those given coordinates, and that is the conclusion of this video.